Hello everyone, welcome back to the channel. Now for this particular video, we're going to continue this core app module by defining the database. One thing under the core application, if you will, in my opinion actually, please do that if you can. Try to abstract as much as you can wherever you implement it here under this particular module. Try to abstract it as much as you can and try to make it adaptable for other projects. At the end of the day, this is the main philosophy behind doing modular clean architecture. The core module should be reused, or at least some parts of the core module should be reusable in other projects. So we're going to proceed with this kind of philosophy from this moment onward in order to define reusable stuff. Basically, this is the case of this particular class that we're going to create in seconds. That's going to be called Pocket Goods Database Manager. We're going to create here a new folder. Let's call it database. It's going to hold basically the database manager as well as the builder class for the database manager. Another folder, entity, that's going to contain the list of entities. And the last folder, relation. Now let's focus on the Pocket Goods Database Manager. Create a new class, Pocket Goods Database Manager. First of all, you have to specify the location of the database, and you're going to use migrator to run the migrations. In other words, to create the database tables, and it's going to basically create your database. Let's first of all create an initializer or a constructor for this particular class. So how to create, first of all, the database under GRDB package. In Swift, we don't have try catch, we have do catch. First of all, we need to specify the location where we're going to store our database. I'm going to create here a variable that's going to hold the value or the path for the app support directory. We will do file manager and default URL. For the first parameter, what we have to provide here is we have to pass the application support directory, user domain mask. We don't need actually this parameter, and the create should be true. We need to access the application directory, will be the app support directory, and we're going to append the location or the folder where we want to put this database in our application. Can do, for example, here database manager cache or something. This is basically the folder where the database is going to be placed, but let's make it reusable. All right, I'm going to create here a parameter. Let's call it placements folder, and it should be nullable. In order to do this very effectively, this is the fallback folder. We'll do here placements folder. If it's null, we will do this fallback folder. All right, now we need to create this particular folder. It's very easy actually. Let's test first of all if the folder does not exist by doing file manager and default file exists, and we have to provide here the path, and the path basically is the app directory and path. If this path does not exist, what we have to do basically is to create this particular folder by doing try file manager and default create directory at app directory. For the with intermediate directories, gonna be true. So if you want to create subdirectories, I think, and for the attributes, null here. Now we have the app directory and we have created where the database manager is going to be placed. We're going to do here database path. Basically, it's going to be the application directory, and we have to append database name and the extension. I don't want to hard code this. Under the initializer, I'm going to add here database name and the database extension. And in order to create the database, we're going to initialize the writer. The writer is basically the object that's going to be responsible for getting the data from the database and writing data into the database. I'm going to create here a public value for the writer. And since we are dealing with saving and retrieving data from database, a public getter for the writer by doing public and the reader, database reader. And we can access the reader from using the writer. Now underneath, create an instance of writer by doing pool. We have to provide here the path, which is the database path. Forgot here to add path in here. Next step, we have to run the migrations. Therefore, let's create a local variable. Let's call it migrator. Let's place it here, migrator. And we need to do migrator and register migration. Here we have to provide the migration version. I don't want to hard code this either. I'm going to come back here and add the migration version of type string, version 1 by default, migration version, and let's open the curly braces, mark or to do, run migrations. We're going to create later on a helper function that's going to run the migration. And the last step here is to do migrator migrate, and we have to provide here in arguments the writer. And the database is going to be created with the specs that we have done here. As a rule of thumb, we should never run our tests in a physical database. Therefore, we need to find somehow to create a in-memory database under this PocketGoods database manager. What I've come up with actually is to create here a flag. I'm going to call it in-memory. By default, it's going to be false. In order to create a memory database is a little bit different than creating the physical database. If in-memory, else we're going to proceed with the same manner that we have done previously. From writer to the top, I'm going to place this in between the else statements. It's going to complain basically that the writer is not being initialized because we haven't initialized yet the writer under the if statement. In memory, we're going to do here writer equal, instead of using here database pool, in memory we use database queue, and there is no path here to be provided. And basically, if we are under test, we need to erase database on schema change. Let's add here the if statement for debug. If in debug mode, migrator, erase database on schema change, and let's close the tag. And I don't want to hard code this. I'm going to add it in the constructor of our class. It's going to be a simple flag equal false. Let's make it a mandatory parameter. In memory, we need to run the migration. Basically, a lot of things could happen here. App directory perhaps does not exist or something wrong with creating the database in general. What we have to do here is fatal error, and we have to specify here the message, error connecting to database and providing the error from the exception. Next, we have to define the migrations. And this is basically the main reason why I have chosen GRDB instead of core data, because it has migrations, and migrations are pretty good when it comes to defining the database. I'm going to create here a private function. Let's call it run migration. What we have to pass here in parameter the database, and this particular function can throw an exception. I'm going to mark here with to do all needed migrations. Let's add here the static keyword, and let's come back to the run migration. Let's delete this. We can do here PocketGoods database and run migrations and pass into arguments database and do here try. Now we have to define the migrations of our database. I'm going to walk you through how to create the first migration, which is for the images table. It's going to be a static function. Let's call it images table migration. And we have to provide here the database, and it can throw an exception. In order to create a table, it's very easy. We need to do try database and create. Let's not hard code the tables names as we have done basically in the Kotlin application. Let's create here another folder. Let's call it miscellaneous. Let's create a new file. Let's call it constants. And I have provided here a simple structure that's going to group everything in a structure called constants, the database name, version, application directory, and the database or table names. Now let's come back to the database manager. And here we're going to use the constant images table. And for the body, how to create basically the table, we have the parameter table. The first column, basically, it's the unique ID of our image, which is a text. And we have to provide here the file name, the preview, and original, which are texts. Now we have to specify the primary key. In this case, the primary key is the unique ID from the Laravel value, or the Laravel unique ID, as we have done basically in the Kotlin version. We need to specify here the reference of the model ID. In other words, model, it belongs this particular entity of type image. Colon, and we have to provide here the model ID, and the type of this model ID is integer, and we have to provide here the reference as well. The table, in this table, image table, it's going to be called model ID, but under products table, it's going to be called ID on delete cascade. Let's create the other one, which is the products table migration. And we have to define the columns. First of all, we have to provide the primary key, which is the ID of type integer, being referenced here under the images table in order to make the relation between products table and images table. For the next fields are pretty simple. We need to define here title, category, price, quantity, and description. For the user's table migration, with the same manner, let's create first of all the table and let's define the needed columns. We have the ID, name, email, and email verified at. For the primary key, it's the ID, and email verified at its date time. We have two migrations to go. The wishlist table migration. We have to create the table first. Let's define the columns. We have the primary key, which is the ID of type integer, and we have to reference the product's ID. Particular wishlist item belongs to the user, and it has a relationship again with product model or the product entity. How to do so? With the same manner that we have done under the images table, we're going to do this for the wishlist table by defining the reference from the product ID. Under this particular table, we have the product ID. In the products table, we have the ID, which has the this particular column name. Likewise, for the user ID, we need to reference in the products table, we have the column ID, which is ID. And in our case, in the wishlist table, it's going to be named user ID. And those are primary keys in both products table and users table. Whenever we delete a user, we have to delete with it this particular wishlist item from the wishlist table. The last migration is for app settings table. Now we have to define three columns, the ID for this particular table, as well as the value is dark theme and the latest visited route. As simple as this, and let's add the keyword static under in the functions. Now we have all the migrations created and defined. Let's use them under the run migration by doing pocket goods, manager, images, table migration, and we have to pass here in the arguments the database. Likewise for the rest of the functions, I would like to add here in this particular class some public functions or useful public functions for some CRUD operations. For example, inserting data, deleting data, and streaming, basically, which is very important, streaming changes from the database. Under Room database, if you use Flow, you're going to have the real-time updates from the database, which is very important for us in order to toggle the wishlist item on and off by the authenticated user. I'm going to do pretty much the same thing here, and luckily under this GRDB package, we have this capability. I'm going to define the first function. We have to insert some entity. It's going to be of type mutable persistible record and table record. This is basically the type of the entity. For the first parameter, it's going to be the entity to insert, and we have to pass here the onConflict of type conflict resolution. It's basically the same thing under Room database, conflict strategy of type conflict resolution. Let's make it optional, and this function can throw an exception. And to insert something using GRDB, it's simple. We have to use try, and we have the writer. Let's add here the parameter database, and inside we have to do here try, because it's going to throw an exception, entity and insert, and we have to provide here in the arguments database on conflict resolution. We have to store this entity into a mutable variable by doing mutable, and instead of using the entity, we're going to use the mutable entity. Let's add another function to delete some records. We have to provide here the table name in order to run the SQL query and the arguments. The type of the argument is statement, arguments. Let's give it a default value statement arguments. And again, in GRDB, how to delete records using the writer. Write, let's provide here the database. To delete a record, we have just to run a simple SQL statement, execute, and we have to provide here the arguments. For the SQL query, it's very simple, delete, and the arguments are basically from the arguments of the function. As simple as this. The stream user function, as a parameter, it needs the user ID of type integer 64. It's going to give us an any publisher, which is in Swift a stream of data. It's basically like a flow in Kotlin, but here we have to access the entity as well as the user model. Therefore, going to leave it for other time. Apply here just to do. Another function that we have to implement here is to stream the app settings yet to be implemented. All right, so we need to create a builder class for this particular database manager. And because I'm a huge fan of builder pattern, I'm going to use here the builder pattern in order to create the instance of this particular database manager. We don't need here the constructor. We have to do it like this. Otherwise, it's not going to be accessible from outside the core app module. We need to provide the database name, database extension, and all those options. Now we need to assign setters for database name, database extension, and whatnot. I'm gonna walk you through the first one, and the rest is gonna be very easy. For example, for the first function, database name, we have to provide here the name of type string. As a return type, it's gonna be of type PocketGoods database builder. We're going to change the value of database name, and we have to return self. This is how to implement the builder pattern. Likewise for database extension, erase database on scheme change, in memory, cache folder, migration. And at the end, we're going to create here a function, build. That's going to build for us basically, or to give us the instance of this particular class. The return type is PocketGoods database manager. And all we have to do here is to fill in the blanks. And that's pretty much it for the builder of our PocketGoods database manager. I think that I'm going to end the video here. For the next video, we're going to define the entities, the relation, and the models. And we're going to come back basically to this PocketGoods manager in order to define stream user as well as application or stream applications settings. I hope you liked the video. See you in the next one, and happy coding.